What's poppin', dogs? Mr. Allen here with some graphing of radical, get it, functions. We're going to graph the parent function, so f of x equals the square root of x, and the transformed radical function, g of x in this case equals 2 times the square root of x plus 5. So let's start out with our parent function, okay? So our x values are going to be 0, 1, then I'm not going to pick 2 or 3 because I can't square root those without a calculator very easily, right? But 4 I can. And 9 I can even do as well, but that might fall off my graph. So we might only do those first 3 there. But if I take the square root of 0, I get 0. Take the square root of 1, I get 1. Take the square root of 4, I get 2. And the square root of 9, I get 3. So let's plot those. We got 0, 0. We've got 1, 1. I've got 4, 2. Yeah, and then 9 is going to go off. So this is my f of x. A lot of times we'll also ask you to label it on the graph, okay? So that's what we did there. Now, my transformed graph, there are ways to do this. You can do it using transformations, and you can do it by just picking smart points and things like that. I'm going to show you guys here with transformations, okay? So again, there's different ways to do this. Certain curriculums teach it differently. I'm going to show you with the transformations here. So first off, what are my transformations? Well, for g of x, I'd have a vertical stretch. So I'm actually going to write this right here. Vertical stretch, or maybe vertical dilation, by 2, and we're going to be moving to the left 5. Okay, so if it's inside, it's opposite, so we're going to go to the left 5. Okay, so how's this going to affect things? And you know what, we're even going to talk a little domain and range afterwards. I think that'd be a great idea, okay? Not using this fourth quadrant here, so I'm safe to write in it. Well, for my x values, that's going to be affected by horizontal movements, or horizontal stretches, compressions, reflections, or moving left. So if I move left from 0, I'll be at negative 5, right? If I move left from 0, I'm going to be 1, 2, 3, 4, 5 over here. So we'll make that negative 5. If I move left here, I'll be at negative 4. If I move left 5 here, I'll be at negative 1. And if I go left 5 here, I'll actually be on my graph. We would have 4. Cool? So all those, I just subtracted 5. It is the opposite of what's on the inside there, okay? Let's double check that. That looks good. That looks good. Beautiful. Now, for my f of x's, it's a vertical stretch by 2. I'm multiplying the output of that radical by 2. So all my y values would get multiplied by 2. 0 is not going to change. That'll become 2. That'll become 4. And that'll become 6. And now I can plot all these points, okay? So negative 5, 1, 2, 3, 4, 5, 0. Didn't move up at all. Negative 4, comma 2, going twice as high. Negative 1, comma 4, all the way up here. And then we've got 4, 1, 2, 3, 4. Comma 6. So that's 4, 5, 6. Cool. Connect the dots. And now I've got g of x. Nice. Wonderful. So as you can see, it gets steeper, like it gets higher faster, right? So that was the vertical stretch, and we shifted to the left 5. That all looks good. How about my domain and range now? Well, domain, if I'm writing it with inequalities, I'll say that x is going to be greater than or equal to negative 5. And my range is still going to be y is greater than or equal to 0. If you see that written in interval notation rather than the inequalities, here's how you'd write it, just in case your teacher uses this. The domain would be from negative 5, including it, to positive infinity, and the range would be from 0, including it, that's the bracket, to positive infinity. Okay, so that's the interval notation way. This is often referred to as like set builder notation. Sometimes you get this like x such that x is always great. There's fancy stuff with fancy teacher brackets. Like, settle down, dude. Don't be so bougie. It's just math. We're just graphing. It's radical. All right, cool. Moving on. Cool. Next one. Let's get to our, we'll do our parent function in orange this time because that seems like fun. So for this one, it's still going to be the same values, 0, 1, 4, and 9, which will be 0, 1, 2, and 3. I could plot all those. Boop, boop, and boop. And that's my f of x, my parent function. And now, the transforms. So this one actually, it has 3 transformations, okay? We have a vertical reflection. I'm actually going to write my stuff up here, okay? No, I'm not. I'll keep it down here-ish. I think that should work out okay. We got a vertical reflection. You could also say reflects over the x-axis. That is synonymous with it. Both are accepted, I would say. We got left 3 and up 4. Oh boy. 3 things happening here. Okay. Well, we're still moving to the left, so I'm going to be subtracting from these x values. So left 3 would be -3 here for x. Nothing else is affecting the horizontal movements. There's no stretch or anything like that. So I'm just subtracting 3. Here I'm going to get -2, +1, and then 6. Now for my g of x, this does matter, okay? I need to perform the reflection first because that is a multiplication thing, whereas the up 4 is addition. And if you respect your dear Aunt Sally, PEMDAS, your order of operations, you know you got to do the multiplication before the addition subtraction. So we're going to reflect, okay? So if I reflect this point, it stays on at 0, 0. Then if I move it up 4, we're just going to get +4. Now, the next one here, my next point, if I reflect that, I'm at -1. And then if I go up 4, I'm up at +3. 3. Then if I take this one, when I vertically reflect it, I'm at -2. If I move it up 4, I'm back at +2. And then for this one, it would have been 3. So I'll just pick a spot 3 right here. If I pick 3, I would reflect down to -3. But then I'd move up 4 to +1. And we do see that these are all changing by 1, whereas these were all changing by 2. The 2 out front did that. The -1 has us decreasing by 1 each time. See how that kind of works out nicely? That is pretty awesome. So now let's plot these, okay? Hopefully, yeah, it looks like we're going to be safe. Okay, so 1, 2, 3, and then +4. So up to 4, which I think is right here. Then we have -2 and +3. Then we have 1, 2, and then we have 6. 1, 2, 3, 4, 5, 6, 1. 1, 2, 3, 4, 5, 6. Yep. Cool. And then I'll go ahead and connect these. And that is my g of x. Woo! Cool. So we did those with transformations, you guys. It's pretty awesome. Let's do a little domain arrange just in case you get asked for it, okay? So for domain, I'm greater than or equal to -3. If you wanted to do that in interval notation, it is -3 including it to +infinity. My range is, this time it's a little different. The highest I get is 1, 2, 3, 4, but I keep getting lower than that. So y is less than or equal to 4. Ooh, boat just went by. It's a beautiful day out there. This is my last video of the day. And then, I'm going outside catching some rays because it's like 70 in February right now. And people are out on the river already. It's March right now. Anywho, not that you would know. Interval notation here. So for this one, we're going to go from smallest to largest. So smallest it gets is -infinity. Largest it gets is +4. So you're going to write it like this. -infinity to +4, including 4. All right? You would not write both of these notations here, okay? You're either going to do these, the inequalities, or these, interval notation. All right? But that's it for this one, guys. So hopefully that helps if you're asked to graph using transformations, filling out T-charts and stuff like that. All fun, wonderful, and excellent stuff, and quite radical, if you will. So thanks for watching. You guys have a great day, and hit the like and subscribe. You know what I mean? See you later.